So we understand that what are the basically process of the recombinations. The first of all we got direct recombination. Second we called indirect recombination. Third we called surface recombination. And fourth we are coming up is the auger recombination. So these are the various type of the recombination, and the recombination and generations takes place naturally in a semiconductor and maintains the equilibrium condition. And we wanted to create in a situation more number of charge carriers in case we have to put a process which is called as an injection process. So by injecting large number of charge carriers, you can create imbalance situation or inequilibrium situation in a particular semiconductor piece of material. This is exactly the mode. Now let's discuss about what exactly the Auger recombination. So the Auger recombination process occurs by the transfer of the energy and momentum released by the recombination of an electron hole pair to a third particle that can be either an electron or a hole. It's so good one. Like what is happening? So this recombination process occur by the transfer of energy. So this is a process of transfer of energy and momentum. It means the energy and momentum both transfer when it is released by the electron hole pair. When an electron hole pair releases energy, then this energy is utilized by the another electron on hole. By this, it means augering of something. It means providing something to someone. Energy is being taken up, energy is being provided. So the example of Auger recombination process is shown in figure 14. Let's we see up here in this one like this. So if suppose if you see here, in this case, if electron is just moving somewhere and coming back, it is releasing some sort of the energy, and this energy is utilized by some another one. Like just taking an example, first of all, we talk about this electron who is just coming back to EV. If an electron is coming back to EV, that means it is losing some energy, and that energy is absorbed by what? This particular electron to go up in a high state. Similarly, the opposite can be possible. If an electron is coming back from high to low, then it absorbs energy under this situation, it releases energy, and this energy can be utilized by another one. So this is a very simple process. If somebody asks to you, comes in a questions, what is the Auger recombination process? So this is a very simple. Under this process, there is augering of energy or momentum from one electron hole pair to a particle, maybe electron or maybe hole, to a particle, maybe electron or hole in this way. So this is basically a way called as an Auger recombination. After this Auger process, the second electron becomes an energetic electron, obviously. But somehow you are getting energy because of some actions. Electron hole pairs are broken up, energy is being released, or electron hole pairs are recombining, then energy process is there. So utilizing that energy by someone. So what is that? After this Auger process, the second electron becomes an energetic electron. It loses its energy to the lattice by scattering events. Now it is energetic basically because it has received. If suppose we are just taking an example of an electron, and this electron is just getting some energy, then what happens? These electrons will start moving here there, and because of this extra energy, because of not any drift, because कोई drift नहीं था वहां पर, कोई आपने कोई शेड्यूल फोर्स नहीं लगाया था, हुआ क्या? रिकॉम्बिनेशन हुआ, रिकॉम्बिनेशन ने अपनी इलेक्ट्रॉन की एनर्जी रिलीज की, होल ने एनर्जी रिलीज की, इस एनर्जी किसको मिल गई? एक बेचारे इलेक्ट्रॉन को मिल गई, एंड दैट इलेक्ट्रॉन इज मूविंग हियर एंड देयर इन द स्कैटरिंग वे. वो इलेक्ट्रॉन स्कैटरिंग वे में यहाँ से वहां मूव ऑन करता है, and once this particular electron is moving here and there, and that releases their energy through scattering process. अब वो अपनी एनर्जी को कैसे रिलीज करेगा? That is releasing because of this basically process of scattering. So this is after the Auger process, the second electron becomes an energetic electron. It loses its energy to the lattice by scattering events. Usually, Auger recombination is important when the carrier concentration is very high as a result of either high doping or high injection level. Because the Auger process involves three particles, the rate of Auger recombination can be expressed. So what is important in it? The most important part in this is that during the Auger process, while we are talking about the Auger process, so during this Auger process, Auger recombination is important. It happens when the carrier concentration is very high as a result of either high doping. भाई जब रिकॉम्बिनेशन हाई कब होगा? रिकॉम्बिनेशन जब हाई होगा when we have a charge carriers more. So when the carrier concentration is very high as a result of either high doping या तो high doping की वजह से or high injection level या injection. See, the doping and the injection is both are the different thing. तो डोपिंग तो जब प्रोडक्शन मेंटेन करते हैं, प्रोडक्ट बनाते हैं, सेमीकंडक्टर पीस ऑफ मेटल बनाते हैं, उस वक्त हो गई. या तो डोपिंग एक वजह हो सकती है और ड्यूरिंग द प्रोसेस यू आर इंजेक्टिंग सम चार्ज कैरियर्स इनकी वजह से. सो बिकॉज ऑफ एनी रीजन इफ यू हैव बेसिकली हाई कॉन्सेंट्रेशन, किसी भी वजह से अगर आपकी कैरियर की कॉन्सेंट्रेशन ज्यादा है, देन it results in Auger recombination process. So this Auger recombination process equation can be taken as, if you see here, this can be taken as R, basically this is a rate of Auger recombination. So R AUG is to be represented by B n square P or B and P square. So B is a proportionality constant and n square and P square is indicating which type of charge carriers are more. If suppose you have more number of electrons, then there is a Bn square. If you have a more number of holes, then you have a Bn P square. This proportionality has a strong temperature dependency. Obviously, क्योंकि Auger recombination किस पे depend कर रहा है? It is depending upon concentration. और कॉन्सेंट्रेशन किस पे डिपेंड करती है? टेम्परेचर पे डिपेंड करती है. सो द ओवरऑल प्रोसेस, जो भी आपका ओवरऑल प्रोसेस है, दैट विल बी टेम्परेचर डिपेंडेंट. पूरा प्रोसेस टेम्परेचर डिपेंडेंट हो जाएगा. सो दैट्स व्हाई दिस इक्वेशंस कम्स अप. So here we are concluding all four recombination process, talking about the Auger recombination here by this diagram, showing that it is providing energy. एक जगह से एनर्जी मिली और किसी दूसरे पार्टिकल को मिल गई. Second is basically called as a surface recombination. We had a word on that कि surface recombinations किस वजह से होते हैं? Surface abnormalities की वजह से local states create हो जाती हैं. It's somewhat like the indirect. फिर हमने क्या पढ़ा था? Then we talked about basically the indirect recombination through this diagram. We have gone through this kind of recombination takes place, and before that we had words on direct recombination process. So we have completed here this direct recombination process. So here we have completed all the four recombination process theoretically, just making it understand how actually they takes place basically. So if you feel anything like that, you may ask the questions on that. So let's begin with this a new section of this one, which is the continuity equations. Please see, the whole unit is describing only one single fact, is what? ट्रांसपोर्ट फिनोमेना ऑफ कैरियर. सारी कहानी अभी तक सिर्फ यही चल रही है. वी आर टॉकिंग ओनली वन थिंग कि कैरियर्स किस तरीके से ट्रांसपोर्ट होते हैं एक जगह से. सो ऑल थिंग्स आर रिलेटेड विद दिस वन. स्टार्टेड विद द ड्रिफ्ट, स्टार्टेड विद द डिफ्यूजन, देन वी केम अप विद द रिकॉम्बिनेशन. रिकॉम्बिनेशन में वही हो रहा है बिकॉज द मूवमेंट इज हियर, रिकॉम्बाइनिंग एंड जनरेटिंग, रिकॉम्बाइनिंग एंड जनरेटिंग. इट मींस दिस इज अ कैरियर ट्रांसपोर्ट फिनोमेना. बिना हिलो डुले रिकॉम्बाइन भी नहीं हो पाएंगे ना जनरेट हो पाएंगे. सो दिस इज ऑल अबाउट द रिकॉम्बिनेशन. So in the previous sections, we considered the individual effects such as drift. We have talked about the drift due to an electric field, diffusion due to concentration gradient. Very, very important terminology. It's a very beautiful line. Just remember about that. Drift due to an electric field, diffusion due to concentration. Diffusion comes because of the concentration effect. And recombination of carriers through the intermediate level recombination centers. और recombination हो जाता है because of what? Intermediate recombination centers are there. So that may also be caused. We now consider the overall effect when drift, diffusion, recombination occur simultaneously. अब actual में ये process तो सारे एक साथ ही हो रहे हैं. It's not like that somewhat diffusion is there, then drift is not present and there is no recombination. So whether drifting is there diffusion is there, and recombination is there. All are present simultaneously. So governing equation is called as a continuity equation. So the equation which describes all these three effects simultaneously within a semiconductor is called as a continuity equation. So now the question comes, if somebody asks what is continuity equation? So continuity is equation is nothing but this is a mathematical modeling which express all the three effects of semiconductor. What are these effects? The effect is drift, the effect is diffusion, the effect is रिकॉम्बिनेशन डन तो तीनों इफेक्ट्स को बताती है वो आपकी कंटिन्यूटी इक्वेशन होती है To derive one-dimensional continuity equation for electron, consider a finitesimally slice with a thickness dx located at x shown in figure 15. So coming up this figure 15. Infinitesimally small. If suppose we are talking about an infinitesimal small slice, it means a very, very small piece. हम किसी चीज के बारे में तब बात करते हैं इनफाइनाइटेसिमली स्मॉल का मतलब होता है इट इज वेरी वेरी स्मॉल टेंडिंग टुवर्ड्स इंफिनिटी मतलब छोटे से छोटा साइज वी हैव जस्ट टेकन अप so we have just taken a very small piece of size and this small piece of size having a cross section area A. This small piece of size, a small slice has been taken. पूरे के पूरे पीस में से छोटा सा स्लाइस हमने ले लिया जिसके बारे में हम लोग बात कर रहे हैं. That is to be taken a very small as dx. हमने dx को assume कर लिया. Here we are applying this voltage. Here we are having a ground terminal. So coming up this one, consider an infinitesimally slice with a thickness dx. Dx thickness के लिया located at x किसी certain position x पर है. The number of electrons in the slice may increase due to the net current. Obviously, if the slice part is there, if suppose we have a complete piece is here, or it means we have a slice. So at this particular point of piece, at this particular piece, on this slice, we have certain number of charge carriers. और वो चार्ज कैरियर्स क्यों होंगे? जब इलेक्ट्रॉन यहाँ से यहाँ पास हो रहे होंगे, यानी करंट ही तो वो रिस्पॉन्सिबल फिनोमेना है, या चार्ज का मूवमेंट ही तो वो रिस्पॉन्सिबल फिनोमेना है जो करंट कंस्टिट्यूट करता है. मतलब दोनों वाइस वर्सा, वी कैन टॉक अबाउट दैट. सो दीज आर द वाइस वर्सा फिनोमेना दैट मूवमेंट इज टेकन लाइक दैट. सो टू ड्राइव द वन डायमेंशनल कंटिन्यूटी इक्वेशन हम ये पूरा लिया. सो नेट करंट फ्लो इन द स्लाइस एंड द नेट कैरियर जनरेशन इन द स्लाइस. ऑब्वियसली बात है इस पूरे के पूरे स्लाइस में if suppose charge carriers are moving, so we are talking only the number of charge carriers available on this slice section. We are talking about only this slice section. इसके बारे में हम लोग बात कर रहे हैं. Now coming up the next one, the overall rate of electron increases is the algebraic sum of four components. The number of electrons flowing into the slice x minus the number of electrons flowing out x plus dx plus the rate at which the electrons are generated minus the rate at which they are recombined with the holes in the slice. So interesting line. Very, very good line. Just be connected and just stay with that. Overall rate of electron increase. It means if suppose we have this particular slice, कितने इलेक्ट्रॉन इंक्रीज होंगे स्लाइस में? पहले 5 हैं, फिर 10 हैं, फिर 15 हैं, फिर 20 हैं, फिर 100 हैं. तो रेट, ये रेट किस बात पे डिपेंड करेगा? जो हमने स्मॉल पीस लिया हुआ है पूरे के पूरे डिब्बे में से, रेट किस बात पे डिपेंड करेगा? सो दैट रेट इज डिपेंडिंग इज द algebraic sum. Algebraic sum because taking a sign convention. कुछ चीजें बढ़ रही हैं, कुछ चीजें घट रही हैं, so that's why we are taking algebraic sum. So the algebraic sum of four components, the number of electrons flowing into the slice at x, कौन कौन से पे? पहला, नंबर ऑफ इलेक्ट्रॉन फ्लोइंग इनटू द स्लाइस x, कितने इलेक्ट्रॉन्स x पॉइंट पर स्लाइस में फ्लो कर रहे हैं, माइनस द नंबर ऑफ इलेक्ट्रॉन फ्लोइंग आउट एट x plus dx. So it is coming to x, how many electrons are reaching to this x point and how many electrons are moving out from this, कितने बाहर जा रहे हैं और कितने अंदर आ रहे हैं. तो दिस इनकमिंग एंड दिस आउटगोइंग. इनकमिंग में से आउटगोइंग माइनस कर दो तो बच गए. जैसे 100 आए, 80 चले गए, so what remains? 20. So that 20 is matter for us. So this one x plus dx plus rate at which the electrons are generated. अच्छा, अब पूरा ये भी होगा क्योंकि स्लाइस है, स्लाइस के अंदर रिकॉम्बिनेशंस भी हो रहे होंगे और जनरेशंस भी हो रहे होंगे. So the rate by which this is being generated. Basically talking about this particular rate कि किस rate से electron generations हो रहा है. What is the rate at which the electrons are generated minus the rate which they are recombined. कुछ generate हो रहे हैं और कुछ recombine हो रहे हैं. तो generation and the recombination both takes place. तो ये भी ध्यान रखेगा भाई 10 100 आए 80 चले गए 20 बचे. अब वहां कुछ जनरेट भी हो गए 15 जनरेट हो गए 10 रिकम्बाइन हो गए तो फिर 5 बचे तो 20 plus 5 now becomes 25. So this is all about the first two components are found by dividing the current at each side of the slice by the charge of electron, and the generation of recombination rate are designed by designated by this equation. So let's talking about this one. So here this is to be taken in terms of J and X, density taken here, density taken X plus dx, recombination rate is taken as the Rn, generation rate is taken as Gn x x plus dx. So Gn and Rn respectively are the overall rate change in the number of electrons in the slice. So now we see del n, basically talking about this small differentiation. So talking about this del n upon del t, a dx equals to j n x a minus j n x plus d minus q plus gn minus rn. So what we talked about, this is the rate basically. So here we are talking about this rate dn upon dt, kitne rate number of rates change हुए. Second talking about this a dx, then talking about gnx minus q, now gnx plus dx a minus q plus gn minus rn a dx. So this is basically the equation created on the basis of four factors. Current electron की डेंसिटी, तो दिस इज जे डिवाइडेड बाय क्यू, करंट आ गया, ए क्रॉस सेक्शन एरिया से पास हो रही है, एक्स प्लस डी एक्स से कितने निकल रहे हैं, कितने जनरेट हुए, कितने रिकम्बाइन हो गए, दैट्स ऑल. सो दिस इज ऑल अबाउट दिस वन. So jn x plus n dx equals to jn x plus del in upon del x plus x so on. Now expanding this equation. अब इस इक्वेशन को एक्सपेंड करते हैं तो कैसे पता चलेगा, x लाइन पर कुछ आए करंट डेंसिटी jn x होगी, प्लस इसको अगर ओपन अप करते हैं तो क्या होगा, jn को डिफरेंशिएट करना पड़ेगा in dx के रेस्पेक्ट में, और मे बी some change of small change of rate may be there. So this is an expansion. So this expansion can be taken into two component, दो component में ले लो बस. अब on the behalf of that यहाँ पर इसका substitution कर दिया. On substituting this one, इसको अगर हम substitute करते हैं, so we finally get from equation 54 to 56. Substitute करते ही ये cancel out हो जाएंगे. इक्वेशन में आपके पास क्या बचेगा, 1/q del jn at dx plus gn minus rn. Now if suppose we are talking about the positive and the negative charge, तो अगर हमने ये इक्वेशन इलेक्ट्रॉन के लिए बनाई थी, होल्स के लिए बनाएंगे तो n की जगह p आ जाएगा, साइन रिवर्स हो जाएंगे, gn की जगह gp आ जाएगा और rp हो जाएगा. Rest of the things remain same. So basically talking about the complete equation, अगर हम पूरी equation के बारे में बात करते हैं, so we can expand these equations like that. If you see del np upon del t, we have to find out. So this equation is because of all factors, np mu n del e upon del x. याद करो ये क्या था, this is because of the drift we were getting. Then we are having this drift of hole. This is diffusion factor, this is a generation factor, and this is basically the difference factor. So this was the equation for this one. Similarly, सेम इक्वेशन डेल पी एन किसके केस में, पी के केस में. ड्रिफ्ट पार्ट, पूरा ड्रिफ्ट पार्ट हो गया इलेक्ट्रॉन एंड होल्स का, डिफ्यूजन पार्ट हो गया, डिफ्यूजन के बाद में ये आपका रिकॉम्बिनेशन वाला पार्ट हो गया. सो सब्स्टिट्यूटिंग ऑल दिस वैल्यू, इन वैल्यूज में सब्स्टिट्यूट करते हैं, देन वी गेट फाइनली इन एडिशन टू कंटिन्यूटी इक्वेशंस दिस पॉइजन इक्वेशंस, दिस इज एन एडिशनल पार्ट, ये तो एक एडिशनल पार्ट हो गया, लाइक दिस इज फाइनली द कंटिन्यूटी इक्वेशन वी गेट. सो हियर we can substitute the current expression from equation 31 and 32 जो हमने पुरानी पढ़ी थी ड्रिफ्ट और डिफ्यूजन की, and the recombination expression from 43 to equation 56 from one dimension case under the flow of injection current carriers in continuity equation, major carriers are np, this one. So this is the finally equations of injection of holes and injection of electron. Just check it out once. If you feel somewhere like you have a doubt, you may ask the questions to me. So if finally we talk about that overall the net current within a piece of semiconductor is constituted by the four effects simultaneously. Effect number 1, drift. Effect number 2, diffusion. Effect number 3, generation. And effect number 4, recombinations. So if you want to find out, if suppose some piece is there, एक strip है, एक line है, यहाँ से कितने electron का generation होगा, how many electrons will be transferring, what will be the rate of change. तो अगर आप वो rate निकालना चाहते हो electron को, you have this complete equation. So put all these values. You need to know concentration, you need to know mobility, you need to know electric field applied. Similarly, you need to know the mobility of hole, you need to know the diffusion coefficient, you need to know the generation rate, and finally this one, the recombination rate, because this is the Np minus Np naught upon tau n. This is the equation taken for this Rp. So here, this is Gp and the Rp is being substituted. We have already calculated that. So all the equations are very same here. We are just only substituting. We are only putting these values here. So this is the first part. We are substituting in this one, drift plus diffusion. And this is the second part, generation and recombination. The generation is same, recombination is substituted like this one. So this is the overall like today's conclusion. I'm not just taking a bit here, just giving you an idea, think it upon, try to explore it more and find out the more questions if you feel on.
Okay, sir.